Today we're going to discuss the virtual pH lab. So I'm in here in your course and I'm going to show you how to get to that lab. So there's a couple ways you can go. You can go into the course materials, click content, and click through the pages in the chemical oceanography module until you get to the assignment. The other thing that you can do, and this is the way I like to get to it because it's a little bit easier, you can click the button for that module. So this is chemical oceanography, and you can scroll down to the virtual pH activity, and we have the instructions linked here, and it also tells you it's on page 8 of the module. So I would expect that if I went to page 8 of the chemical oceanography module, I would find some information about pH. So if you're going through this lab and you need a little bit of help with pH, or you don't really understand pH yet, you can go to page 8 of the module and there'll be some help here. As students start asking questions about the module, they'll get posted underneath here. I'll post a link to this video and any documents that I edit or anything during this video. They'll all be posted right here. So this one downloads. So I'm going to go ahead and I'm going to click on it. And I'm going to bring it up and we're going to see what happens. I haven't done anything with this lab yet. I'm new to it just like you. So first thing I'm going to do is I'm going to click on this and I'm just going to copy it and I'm going to paste it into a new window. And it says Adobe Flash Player is blocked. So I'm going to look for add-ons. I might try add-ons here and let's see what we can do here. Okay. Let's search for Flash. Okay, so here's what you're going to do. Right now, this is blocking sites from running Flash. If we click this, it'll say ask first. So now, now it should work. So of course it doesn't. Let's try again. Okay, so basically what happened is when I reloaded this website, I got a little pop-up and it said, do you want to allow Flash? And I said yes. And so then the lab popped up. So let's see what's going on here. First of all, I'm going to zoom in on this a little bit because I don't want it to be so tiny. I want to be able to see it and I want you to be able to see it too. Okay, so we read the introduction, which is this information right here, and we'll answer the following questions. What does the pH of a solution measure? How does pH paper help to determine the pH? What is the range of the pH scale? And what is the pH of an acid? And what is the pH of a base? And what is the pH of a neutral substance? And so you'll get that in this introduction. These two paragraphs is going to answer all of this. Okay, so I'm just going to highlight this right here, and so you have that. Next it says, write down the pH and the color of the paper for the following substances that you tested. Okay, so right now we have lemon juice in 1, tomatoes in 2, shampoo in 3, water in 4, vinegar in 5, and seawater in 6. So I'm going to take this pH paper, I'm going to put it in here. Okay, and I'm going to look at it, and we're about at 3. Okay. Okay, so I'm just going to I'm going to put 3 right here. The color was orange. And is this an acid, a base, or a neutral? Okay. It is an acid, right? Because it has a pH less than 7. Okay, so there I go. I just gave you the answer to this part. So let's go ahead and write that right here. Acids have a pH less than 7. Okay, that means that bases have a pH more than 7. And a neutral substance is exactly 7. Okay, so there we go. I've gone ahead and I've given you those answers. Okay, I'm going to leave that part up. Okay, so you're going to test all of these. Okay, so not just one. Uh-oh, I did the wrong one. Oops. That's okay. I'm going to dip it in here. Now I'm going to take my little strip. It looks like it's 4. Okay, so tomatoes, I'm going to find tomatoes. Those are going to be 4. That was like, I don't know, light orange. And it's an acid. Okay, and if you lose some of your bar, you can just kind of do that. Okay, the next one is shampoo. Okay, so I'm going to look at this. So do you see how that's 5 and 6? It's yellow, but it's kind of like a mustard yellow instead of that bright yellow, so it's pH of 5. So I'm going to take my, right here, I'm going to write 5 here. I'm going to write mustard yellow, you could write dark yellow, you know, something like that, and it's still an acid. Okay. Now let's go to the 4th thing, which is pure water. Okay, let's see. Okay, do you see how it's this light green? So that's a pH of 7. Okay, so that's 7. I'm going to put light green. And it is neutral, right? Because it's not less than 7, it's not more than 7, it's exactly 7. I'm going to test this next thing, which is vinegar. Okay, let's look at that. Vinegar is 3, just like our lemon juice. Okay, so I'm going to write 3, orange, and acid. Okay, now the last one for me is seawater. And I'm just going to kind of take a peek at this. Let's see. Okay, it's about 8. It's not quite 7. It's not quite 9. It's right at 8. So I'm going to label this. Now, remember, you guys are going to do all of these. I'm not doing all of them. I'm just kind of showing you what they would be. I'm going to say like just regular green, not light green, not dark green. And since it's 8, it's a base. Okay, and so you guys will finish the rest of these. And the way you do that is you can just kind of like switch up here. Let's see if we can switch them. Let's reset, and we can pick some new solutions. There you go. Do you see how you've got different solutions here? And you can just keep resetting them till you get all of them. Okay. Now we're going to go to a different lab. This is called a PhET lab. Okay, so this is like a physics website, so I'm going to just paste in here. And let's see what we're supposed to do here. Okay, we want to click on the tab labeled micro. Do you see that right here? So that's not the one that initially comes up, it's right here. Okay, so here we go. This one is going to have us experiment with different solutions. You're going to use each of these, okay, and we're going to just see what's going on. So let's start with drain cleaner, and let's see what's going on with our bar graph. I just kind of want to play with it a little bit. Do you see how these are changing over here on the left? Ew, spit, that's gross. Okay. Ew, vomit, yuck. Okay, so here's drain cleaner, and it's showing us the H3O plus concentration and the OH minus concentration, and then the pH. So that's what we're going to write down here. Okay. So I'm going to write down the pH. The pH is right here. It's 13. The H3O plus concentration is 1 times 10 to the negative 3. So let me show you how I'm going to write that. Or to the negative 13. I'm going to write it like this. And this is kind of like an easy way to do it. That E means times 10 to the. Okay, so I'm going to write that one that way, and I'm going to write this one the regular way, I guess, the way that you guys do it, just so you can kind of see. You know, so there's a couple ways you can write it, just so you guys know. Okay, so these are the two ways you could write this. And then you'll go to hand soap, then blood, then spit, then water, and you'll do all 11. Okay, then we're going to make a custom liquid. Okay, so let's see how we do that. I'm going to restart it. I'm going to put, here's some, let me see, what can I do here? I'm going to add some water, add some more soap. I'm going to add water up to 1 liter. Okay, so now my custom liquid has a pH. Okay, so it's not letting me do that. Okay, it's going to have a pH of, I'll write it here, of 9.71. The H3O plus concentration is going to be 1.9 e to the negative 10. And then the OH minus concentration is 5.2 times e to the negative 5. Okay? And then it says, what is the relationship between the concentration of hydronium and hydroxide? Okay? Just so you guys know, I'm going to write this here. Hydronium is H3O plus, and look, this isn't an O, and hydroxide is OH minus. Just so you guys know those terms, because it's probably in the content, but just so you know. And I'm going to just highlight that so you know that that's there. If a solution is neutral, how many hydronium ions are present? If a solution is neutral, how many hydroxide ions are present? I'm just going to give you a little hint here. We can restart this. Okay, and this is if you just do water, it has a pH of 7. So it's showing you here exactly how many hydronium and how many hydroxides are here. So I'm just going to make a little note here. Hint, make a new solution that is neutral. Only water, and write down the concentrations. Okay, so it's not expecting you to, like, you know, memorize it or whatever. And then you'll just submit your assignment in the Dropbox. So you don't need a lab report for this. It doesn't say anything about a lab report. You're just going to want to answer these 6 questions. You're going to want to fill out all of these. You're going to want to do all of these. And then you want to make some random solution. Mine was that weird hand soap and water solution. And then you're going to want to answer these 3 questions, and that's it. And that's all you need to do. I'm going to highlight here, test all of these. Okay. And I will post this document that I've edited and highlighted and things like that. I will go ahead and post that in this newsletter under virtual pH activity, so you can edit my document if you want. You don't have to. So hopefully this video was helpful.